In this video, we're going to talk a bit about the sandwich theorem. And the sandwich theorem is useful because it helps us to evaluate difficult limits. And the sandwich theorem can also be called the squeeze theorem or the pinching theorem. And what the sandwich theorem says is, suppose we're given three functions. So we'll suppose that we have some g of x, which is less than or equal to f of x, but f of x is itself less than or equal to h of x. So what you see here is that f of x is sandwiched. It's in between g and h. It's bounded below by the function g and above by the function h. And we want to consider that we are considering these functions for all x value on an open interval, which we commonly call I, which contains our c value. Okay? So, if we know that the limit as x approaches c of g of x equals the limit as x approaches c of h of x, which might be some value L. So we're looking at the function which is bounded beneath g and the function bounded above h. And we're saying both of those functions, the one above and the one below, they both go to this value L. If they both go to L, then the function in between them, then what we say here is the limit as x approaches c of f of x must also go to L because it's squished between them. And so since h and g pinched at that one point, they bound, one is above and one is below. They have now sandwiched f in between them, and f must also go to that point. Okay, so that's what the sandwich theorem says. And in maybe some more or different layman's terms, we could say if the bottom limit is equal to the top limit, then the limit of the function in the middle, the limit that is sandwiched, would also equal the same value. So if the bottom and the top limit equals some value L, then the one in between must also equal that value L. So let's look at one example. So for this example, we are given 1 minus x squared divided by 4, that is my lower function, and 1 plus x squared over 2, my upper function. And u of x, I know that no matter where I am on this function, that u of x is always going to be between those, right? So I have a parabola opening down for 1 minus x squared over 4, and I have some parabola opening up for 1 plus x squared over 2. And we know that u of x is in between them. So I don't know how crazy u of x is. I know that it's bounded. It's going to have to be smushed somewhere in the middle. So regardless of how complex that interior, the inside sandwiched function is, I can determine the limit of it if I know the limit of the two bounding functions, the function that bounds it below and the function that bounds it above. And if both of those limits go to the same value, some point, if they meet at some point, then we would know the limit of the interior sandwiched function. So in order to solve this, we would look at the bottom of the sandwich, and the bottom of the sandwich would be saying, well, let's look at the limit as x goes to 0 of 1 minus x squared over 4. And if I were to evaluate that, that would be 1 minus 0 squared over 4, or 1. And then I would look at the limit for the top of the sandwich. Okay, so the top of my sandwich, that's the limit as x goes to 0 of 1 plus x squared over 2. Well, that would be 1 plus 0 squared over 2, which equals 1. So since the limit below and the limit above are both equal to 1, we know the limit of the function sandwiched is equal to 1. So the way I would write my answer here is I would say then, and in math this double barred arrow is a symbol for then. So then, by the sandwich theorem, we would just state which theorem. By the sandwich theorem, we would know the limit as x approaches 0 of the function u of x, the function sandwiched in the middle, must also equal 1. And so I have a graphic that I'm going to pull in here. So as I drew before, we had the limit of the upper was a parabola opening up and the lower is a parabola opening down. And you see that they both go to this same point. As x approaches 0 from both the left and the right side, my y value ends up at y equals 1. So that means the function in the middle, and I don't know how crazy or oscillatingly wild it is, I know that also has to go to 1. So that's the idea behind the sandwich theorem.